All right, here we go. This is Math 2 Unit 10. This is the review worksheet here, and I'm going to work through as much as I can before I head off to improv tonight. So here we go. We have the graph of f of x is shown. State whether each statement is true or false. All right, so let's see. F of x is decreasing when x is greater than 0. All right, so here is our x-axis right here. This is our x part. So we can draw this here. Let's make it a little bit easier for me to look at. That's our x, and here is our y. Okay, so the x is decreasing when, the graph is decreasing when x is greater than 0. So here's 0. Is this decreasing as we go this direction? We would say yes, that is decreasing. So that would be a true statement there. The axis of symmetry is y equals 0. All right, let's think about this. Be careful. Y equals 0 is right here. Okay, so is everything bending around that point? Now, when we say y equals 0, you have to think about a line. This becomes our line, y equals 0. Is everything bending around that line right there? The answer would be no. Where is our axis of symmetry? Axis of symmetry is right here, but what is this line called? This line right here is referred to as x equals 0. So the axis of symmetry is not y equals 0, it's down here, x equals 0. So I'm going to write true down there. I know I'm doing it in a different order, but that's okay, you get the idea. Okay? Alright, next, let's see, let's look at the next one. So that makes this one false. The maximum value of f of x is 9. Okay, so the maximum value of f of x. The f of x means that's our y, the maximum y value is going to be 9. Is this a maximum right here? This point is going to be 0, 9, so that is our maximum value. That is true. 2, 5 is a solution. Solution means it is on the line. So we look at 2, 1, 2, and we go up 1, 2, 3, 4, 5. It certainly looks like it's on there. As far as I can tell, I'm going to say that is a true statement. For the next one, negative 1, 3, negative 1, 1, 2, 3, this point right there, is that a solution? Is that on the line? We would say no, that is not a solution, false. 3, 0 is an X intercept, 1, 2, 3, 0. Is it crossing the X intercept right there? Yes, it's crossing the X axis right there, that is true. 0, 9 is an X intercept of f of x right here. Is this an X intercept? No, that's a Y intercept, so that's false. It's actually a Y intercept. Alright, we did that one already. The vertex is 0, 9, which is right up here at 0, 9. That's our maximum. That is true. And the value of x when f of x reaches its maximum is 0. So when it gets to the maximum here, what is our x value right there? This is x is at 0. That is true. So using f of x in number 1 above, determine the domain, remember domain are the x values of f of x, and the range, the y values. So our domain of f of x is going to be what? Well, remember this one? All real values, all real numbers. Everything, every value of x is going to work. That's a normal, regular number. Now the range for y is going to be what? It's going down, so we're going to say it's less than or equal to, what's our maximum value? 9. So what values of 9 are going to work? Anything from here down is going to work. Those are all going to be fine values of y. Determine the rule for translating negative 1 x squared, for this g of x, to f of x. Okay, so if we are at f of x is x and 1, and we're going to go to negative 1, what's the rule we're going to say here? Okay, so what's happening is x is going to be x and y is going to be a negative y. Negative y. Alright, number 3. Number 3. Select the values of the quadratic function and k of x shown in the table, sketch it, and determine some things. Okay, so we're going to sketch this out here. We're going to have negative 6, 1, 2, 3, 4, 5, 6, and negative 7. So we'll say 1, 2, 3, 4, 5, 6, 7. So we'll be off the graph. That's super handy. That's okay though. We'll put it right there. Negative 5 is at 0. 1, 2, 3, 4, 5, and we're at 0. Negative 4, we're at 5. 1, 2, 3, 4, and 5. At negative 3, we're at 8. So this is awesome. So 3, 1, 2, 3, we're at 8. So that's 5, 6, 7, 8, maybe about here. Negative 2, we're at 9, so a little bit higher, maybe about here. And negative 1, back to 8. And 0, we're at 5. And 1, we're at 0. And 2, we're at negative 7, which is down here again. Okay, well that is super exciting, isn't it? So when we graph this, we're going to go up and up out of our graph, come back down, 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 and there we are. Okay, so that's what we're looking like with our graph. Fantastic. The X intercepts. So where does it cross the x-axis? It crosses it here and here. So where is that going to be? That's when y equals 0. Y equals 0. That happens when? At negative 5, 0, and also at 1, 0. That's what an x-intercept is. Our y-intercept, that is when x equals 0. X equals 0 right here. When x is 0, y is 5. Find the value of x when kx is at its maximum. So our maximum point is right here at 9. That's our maximum. So the value of x is going to be negative 2. What's the maximum value of k of x? So the maximum value, that's our kind of a maximum y value, is going to be the 9. So we'll say 9. So that's our maximum, right? That's our point. If we put it as a point, it'd be negative 2, 9. K of x is increasing when x is what? So when is this graph going up? Well, looking at your axis of symmetry, we're going to be going up when? When x is less than 1, 2. So when x is less than 2, or negative 2, sorry, when x is less than negative 2, which is right here, the graph is increasing. It's decreasing when x is greater than negative 2. Okay, number 4. Match the equation to the number that reveals the characteristics of the equation without changing the form of the equation. Alright, so which one helps us reveal the maximum value of m of x? We're looking for maximum value, looking for 0, or the x intercepts, and we're going to find the value of m of x when x equals 0. So that would be our x equals 0 is our y-intercept, right? So we're looking for a y-intercept, x-intercept, and maximum minimum values. Okay, so maximum minimum values, that's always found right here in our vertex form. So number 1, or sorry, I don't know how to put this here. I don't know what's A, B, and C. So we can make this 1, 2, and 3, I guess. Oh, I see what they're doing. So C, sorry, goes with, that's really weird. Okay, so how you want to do this? If you want to draw a line, that's fine too. This is maximum minimum, no problem. We can see our maximum here is going to be 2, 27. Or in this case here, it's actually, yeah, maximum. For the one that reveals the zeros, we're going to go with A, because that tells me my x-intercepts right there. When x equals 0, we can find it real quick. And the one that tells me a y-intercept is in standard form, which is here. All right, so and I guess how we do it here, A goes to number 2, B goes to number 3, and C goes to number 1. I guess that's what I wanted that there. Just arrows are fine. 5. In order to factor the left side of the equation, choose from the number box to fill in the blanks. Here we go. So we have 2x plus 7 minus 15 equals 0. We're going to factor this out. So we're going to put a 2 here, and we could put a 1, I guess, but you don't need to, but we could. It's fine, just to use some numbers here. So we're going to use a 2, and we've used a 1. All right, for 15, I can do 5 times 3. That works just fine. Let's plug it in and see what happens. If I put a 5 there and a 3 there, my outside becomes 10, my inside becomes 3. Okay, now there's nothing wrong with that except that that's 15, but I need a negative 15, I need a positive 7. So I need to make this positive, and this one needs to be actually a what? A negative 3. So if that's a negative 3, now I have negative 15 there, And then I have a 10 minus 3, which equals 7 for my middle term right there. So I've used a minus 3, I've used a 1, and I've used a 5. All right. Sorry, this way of doing things I don't work this way too much. I like just guessing my numbers, but that's okay. So plus and minus 3, great. Over here we have a 5x, so that's going to be a 5. That's going to be a 1, so I guess we can use the same number twice. Okay, cool, we'll do 5 again. And then I have a 10. I can get to 10 by doing 10 times 1 or something like that. I know my middle term has to be 50. So I'm going to use a 10 right there, so I end up with a 50 there, and that can be a 1, and I can make it a 1 there. This has to be a positive, but I need to get to 51 with a negative 51. So this needs to be a negative 10 and a negative 1 in order to have a negative 50 and a negative 1 there. All right, so that's going to work for me on that one. Okay, let's turn the page and look at the next page. All right, here we go. Number 6. For each of the following, state the vertex and determine whether it has a maximum or a minimum. Okay, so they're in vertex form already. So what we're going to do for the vertex is we're going to be able to take a look at the opposite of this one, which is going to be 5. And that value right there becomes our y value for 5, 2. Let's do the vertexes first. Opposite is 5, and this value makes it a 2 for the y. Here, vertex form, so opposite is negative 5, and our y value is 2. Now in terms of these are maximum or minimums. Okay, let's see. This is a negative in the front. That negative value means we're going to be curving down. So whatever that vertex is now going to be on the top of that curve, so it's a maximum. Here it's positive, so we're curving up. So whatever that number is, it's going to be a minimum. Here again it's positive, so we're curving up. So that's going to be again another minimum value there. For each of the following, state the axes of symmetry. That's going to be the place at which it's going to reflect and cross over. So that's not too bad here. So if we look at that's going to happen at the vertex. So our vertex again is going to be what? In this case it's -1, -3. That's our vertex. So what's the x value at which it makes the curve do its thing? This is going to be a curving down. That's going to be at -1, or we could say an x equals -1. For here, the x value, the place where it curves, is going to be x equals -5. And here it's going to be where x equals what? -4. Okay, and you can just use your vertex there to say what that's going to be. If you want to put the vertex form first, you can. It's not necessary. Determine if each ordered pair is a solution to the function right there. So let's see. Here's our work. So we're going to try 0 and see if we get a 1 out of it. So we have -3 times 0 squared plus 1. All right. -3 times 0 is 0 plus 1 equals 1. Does that match my goal? Yes, it does. Here we go, the next one. -3 times a 2 squared plus 1. All right. So -3, 2 squared is 4 plus 1. -3 times 4 is what? That's a -12. -12 plus 1 equals -11. That would be a no. For the next one, we don't really need to do that because we just did 2, so it seems kind of silly. So we just did it there and we proved that it's -11, so that's also going to be a no. And here we have 1, so we'll do -3 times 1 squared plus 1. So 1 squared is 1. 1 times -3 is -3 plus 1. -3 plus 1 is -2. Does that equal 8? No, it does not. All right. Next one, number 9. Given the graph below, answer the following questions. All right, what's the vertex? The vertex seems to be right here at that point, which looks like it is at 0, 5. Is that a maximum or minimum? Well, that is the top value. That's going to be a maximum. Axis of symmetry. Where does it make its nice little fold over? So you have a reflection going on that line. That's when x equals 0. Right there at that spot, when x equals 0. The graph seems to be increasing from here to here. It's increasing when what? When x is less than 0. This is the increase side. And over here, when x is greater than 0, we are decreasing. What is the transformation of the graph f of x to g of x from here to there? Well, let's see what's taking place. What are we talking about in this one? Okay, so in this case here, my vertex in this case is going to be at 0, 0, right? That's where that's just going to be. I could graph it and plot it, okay, and it's going to look like this for the first one. No problem. This one though, I have a vertex at where? -4, -2. So we're going to move over 1, 2, 3, 4, and then down 2. So that's what my graph will look like. It'll be the same shape for the most part there, and it's going to look something like that. So what's the transformation going to be? From this one to that one, I'm going to move over left 4 and down 2. So this tells me left, that tells me down 2. The next one, here we are at x squared, which again is going to be where we start from, right? So that's our x squared. And then we have our vertex. Our vertex is where? 3, 1. So move it over 1, 2, 3, and up to there. So that's our new one. So the transformation from here to here is what? We're going to go right 3, up 1. And that is what our transformation is for number 11. Okay, let's turn the page over and take a look at number 12. Okay, the graph at the right, shown below, sorry, and the table represents some values for g of x. Which graph, that's right, this is f of x here, this is g of x. Which graph has the greater maximum value? So let's see where our biggest number is over here. We have 0, 1, 2. Our biggest value is right here at 2. So the maximum for this one is 2. The maximum of this one, it looks like this is our origin here, is at 1, 2. This is going to be 1, 2, 3. This is point -3, -2 is the maximum. So this one has a point at 3, 2. 1, 2, 3, 1, 2, point there. That's my g of x. Here's my f of x, here's my g of x. So which one has a greater maximum value? I'm going to go with g of x because it's above f of x right there. The value of x when g of x is at its maximum is greater than the value of x when f of x is at its maximum. Yes or no? Well, let's take a look at this here. So this graph, if I was to plot some more points out here, we have it at 1, 0, 1, 0, here's that one there. And I also have 5, 0 right there, all right? So that's my graph so far. Okay, I could do some more, 0, 2.5, 1, 2.5, and over here at this one. So this graph kind of goes over that one like this. This is my g of x. This is my f of x. So the value of x when g of x is at its maximum is greater than the value of x when f of x is at its maximum. Well, that's a great question. Is the value of g of x at its maximum going to be greater than f of x when it's at its maximum? The answer is going to be, here's what's weird. It looks like you want to say yes, but because this goes on into infinity, right? It just keeps going over, right? The domain keeps going that way forever and ever and ever. They're actually going to be equal. There's never going to be a place where like one actually stops. So we would actually say no. Kind of a strange question. State the x intercepts of g of x. So where does it equal 0 at? So that's going to be here and here. So g of x intercepts are going to be at 1, 0 and 5, 0. All right, state the zeros for this one right here. To state the zeros, the easiest way to do it is to factor it. All right, so let's do some factoring. We have x. For 14, we can do 7 and 2. I want a minus there, so I'm going to put a minus and a plus. So I get -14, and the outside is a 2 and a -7 to get the -5 there. So we're good. So what are my zeros? I could set them equal to x minus 7 equals 0. So now x equals 7. And x plus 2 equals 0. Subtract 2, so x equals -2. So my zeros are going to be what? 7 and a -2. Those are my zeros. And I could write them like that, or I can write them as a -2, 0 as a point. And those are fine too, because that's when y equals 0. All right, so those are all fine ways of saying that one. Number 14, a ball is thrown in the air and is represented by this equation, where ht is the height of the ball and t is time. Find the time it takes for the ball to reach the maximum height. So the maximum height is going to happen where? It's going to happen at that vertex, which is going to be 3, 23. So how much time did it take to get the maximum height? We would say 3 seconds. The domain. The domain are the values of x that make this true. Now, because we're throwing a ball in the air, it's going to start at some place and it's going to come and land at some place. That's the nature of throwing a ball in the air. It doesn't go on forever. So if our maximum height was here at 3 seconds, we can say if it took 3 seconds to go from there to there, it's going to take 3 more to fall to the ground. So 3 plus 3 is going to be 6. So our domain is actually going to be, in this case here, we would say that our domain, is going to be between 0 less than or equal x less than or equal less than or equal 6, because that's the value of x there. Now this is going to be how many seconds? I guess, well, it's a good question, because that's how many seconds it takes. It's hard to say because you're talking about time in this case here. So time's going to continue forever, but because the ball stops, does time stop? It really doesn't. This is kind of a weird question. You could say that time can be anything greater than equal to 0, right? Because time's going to keep on going forever because it is time. That's how time works. It doesn't really stop. But if you're doing a stopwatch, you would press stop when it hit the ground. So you might say 0 to 6. That's okay. For our range here, we're going to say that our range is going to be, in this case here, I would say that our range is going to be from wherever you threw the ball at to the place where you're going to, from 0 up to its height. Height is 23. So I would say the range is going to be y is less than, well, again, it's going to hit the ground. So I would say 0 less than or equal to y less than or equal to 23. You might say y is less than or equal to 23, just can't be negative. So I'm not really positive on what they're looking for that question there. You might want to kind of ask your teacher a little bit more for clarification on that one, just for the things it's asking. Okay, but you're pretty close there. We're going to be okay. Alrighty, cool. Let's move on. Okay, so over here. Vertex. It's in vertex form, so we can do -1, comma, -2. That's our vertex there. We could plot that and go -1, comma, -2, and we're good to go. We know we have a negative in front, so we're going to be curving down. We know that much. It's going to be true. We could also figure out our axis of symmetry is going to be at x equals -1. That's going to be where we curve stuff at. If x is equal to 0, if x is equal to 0, -2 times 0 plus 1 squared minus 2. That's -2 times 1 minus 2. So -2 minus 2 is -4. So if x equals 0, we're at -4, which is 1, 2, 3, 4, somewhere about here, right? Wait, no, 1, 2, 3, 4, about here. And that makes us over here at 4. So our graph is going to look like so, in that range there. So our domain, our values of x that are going to work are going to be what? All real values of x. Our range is going to be y is going to be everything less than or equal to -2. Okay. I'm going to pause right there and I'll come back and keep finishing it after some improv. Alright, here we go, picking back up from after improv. So we're going to begin here at number 16. It wants to know the X intercepts. So the best way to do the X intercepts is going to be to put this into our intercept form if we can. So we factor that out. I can factor out the negative, and I'm going to do X, change the sign, and well, let's do this. I'll factor out the negative first. So I have X squared plus 4x plus 3. Now I'll factor this part out there. and we have an x and an x, 3 times 1. We want this to be positive, positive, so I have 3x plus 1x is 4x. So what are my x-intercepts going to be? Okay, this is where it gets a little bit funny, right? Because that negative up there in front. Well, I wouldn't really worry about it too much. So what we're going to say is we're going to say that our x-intercepts are going to be when x is what is x plus 1, set it equal to 0, x is going to equal to negative 1, x plus 3 equals 0, x equals negative 3. So at negative 1, we have an intercept, and at negative 3, we have an intercept. For our vertex is going to be found at the high point, so to speak, right? So what is our high point going to be in this situation? So we plot a point here. Let's just see where we are on the graph. We're at negative 1, 0 for an x-intercept. We're at negative 1, 2, 3. Oh, sorry, 1, 2, 3, 0 for our other intercept there. We know it's negative, so we're going to be going down in this direction right there. Okay, so that tells me that my axis of symmetry is going to be right here at, in this case here, negative 2. This is where it's going to curve around in order to get those 2 points there. So if my axis of symmetry is at negative 2, I'm going to plug negative 2 in, and that's going to tell me my maximum minimum value here. So if I plug negative 2, and I could plug it back to the original equation if we chose to. So y equals, and we could do negative 2 squared minus 4 times negative 2 minus 3. And again, I could plug this into any one of these things over here and be just fine. So negative 2 squared is 4, but it's still negative, so negative 4. And then I have 4 times negative 2, or I could think of it as negative 4 times negative 2, which is going to be a positive 8 and a minus 3. Okay, so now I have a negative 4, a negative 3, that's negative 7, and a positive 8 make a total of 1. So when x is negative 2, y is at 1. So that becomes my vertex. It's me right here at 1, and we're curving down like that. That's how that one's going to go. Okay. So the order that you do these isn't really super important, and they're always listed a certain way, but if it helps you go one way first, that's okay. All right, 17, we have x and y intercepts, so again, I'm going to factor that out. For an x and an x, I'll do 5 times 1 to get the 5. I want it to be negative, so one of these will be negative, one's positive. So let's make this negative and that positive. That will give me with a positive 1 and a negative 5, which works for the negative 4 there. So our intercepts are going to be the opposite of this. We're going to have 5 and negative 1. So our intercepts are at 5, 0 and negative 1, 0. And we plot that out there. 1, 2, 3, 4, 5. Put it there. And negative 1, which is right there. The distance between here and here is about 6. So let's find the middle at 3. 1, 2, 3, which is going to be at x equals 2. So our line of symmetry, our axis of symmetry, is at x equals 2. Now we'll plug that back into our equation. Now again, let's use this one this time. Let's say y equals x minus 5 times x plus 1. Let's use it in this one. Last time we used the big equation, the quadratic thing. Let's use this. So let's be 2 minus 5 times 2 plus 1. 2 minus 5 is negative 3. Oops, ran out the page there. And then 2 plus 1 is positive 3. That equals a negative 9. So when x is 2, y is negative 9, and that becomes my vertex for that one right there. All right, cool. Let's turn the page and look at number 18. 18, f of x equals x squared, g of x equals g to the x. Evaluate the average rate of change. Remember, average rate of change is going to be the y2 minus y1 divided by x2 minus x1. All right, in this case here, we're looking at the change of f of x from 0 to 3. So for our x value, we're talking about when x is 0, what do we come up with for f of x? That becomes x squared. So 0 squared is going to be equal to 0. So our y is 0. And then when it's 3 squared is going to be equal to 9. So for our rate of change for the first one, we're going to do our y2, which is 9, minus our y1 over our x2 minus our x1, which is 0. So this becomes 9 over 3, which reduces to 3. So our rate of change for f of x is 3. For b, we're also going 0 to 3, or sorry, for b, well, for g of x, and we have 3 to the x power, so we have 3 to the 0 power. 3 to the 0 power is 1, so be careful there, all right? And then 3 to the 3rd power, so that is 3 times 3 times 3, which is usually going to be 27, okay? So our y2 is 27 minus our y1, minus our x2 minus our x1, which is 0. So we have 26 over 3, which I can then say 3 goes in 26 8 times with 2 left over. So I could write 26 over 3, or I could write it as 8 and 2/3. What do the average rates tell you about the functions f of x and g of x? What we can see here is g of x has a greater slope, right? So it's going to be steeper. If you were to graph that out, it's going to be steeper slope like that than f of x. But that happens between, which should be clear, 0 and 3. It's because we're using the same section there. It might change someplace else between 0 and 3. G of x has a steeper slope. How are the average rate of change different, and why? We would say the slopes are different, and that's because the equations are different, and that's because the equations are different, you get a different result. And that's how that works. Number 19. There we go. We have the little rocket going again. We did one of these in one of our lessons. So we're going to do true or false here. We can see it's in it's in this case here, vertex form, right? So our vertex is going to be at 1/2, 36. That's our vertex. So we can see that occurs right there. That's our vertex point there. The maximum height of the rocket is at 36 feet. That is going to be true. That's our vertex. True statement. The maximum height is 2 feet. Well, you wouldn't say both these are true. So if 36 is the height, then 2 is not the height. Why is that there, though, is a good question. That's there because you might look here and say, oh, look, there's a 2. Yeah, but that 2 has to do with time. So read your graph. It took 2 seconds for the rocket to hit the ground. That is going to be a true statement because we see it lands here in 2 seconds. The rocket started at an initial height of 30 feet. Well, 30 is here. It started above 30, so that would be false. The rocket was increasing in height between times 0 and 0.5. Is it going up between here and here? Yes, it is. And then it starts to go down and decrease from that point on. Okay, number 20 to 23. Find the zeros by the method of your choice. If there's no solution, write none. All right, so here we go. For this one, we could do 2x squared equals 32. We could do that there. And then we could say that we divide both sides by 2, and x squared equals 16. And I can take the square root of both sides, so that x equals plus or minus 4. That could work. I could also do factor a 2 out of it, and I could have 2, which is then going to be, I have x squared minus 16, right? And if I do this one here, I do 2 times, this becomes a factored out x plus 4, x minus 4. And when you do it this way, what are your solutions? Minus 4 and plus 4. So those are my 2 zeros are going to be plus and minus 4. Okay, this one, find the zeros once again. All right, I'm going to go ahead and move this around a little bit. I'm going to do this, make this x minus 1 squared equals 49. Why? Because I know that 49 squared root of 49 is 7. So I'll do square root of both sides. So x minus 1 equals plus or minus 7. Add 1 over there so that x equals 1 plus or minus 7. Well, 1 plus 7 is 8. And 1 minus 7 is negative 6. So my 2 solutions for this one are going to be 8 and a negative 6. All right, over here, same idea. I'm going to go ahead and move the 50 over there. So I have negative 2 times x plus 3 squared equals negative 50. Divide both sides by negative 2. So x plus 3 squared equals 25. Square root both sides. So that x plus 3 equals plus or minus 5. And again, that's going to subtract 3. So x equals negative 3 plus or minus 5. So negative 3 plus 5 is going to be one solution. Negative 3 plus 5 is 2. And negative 3 minus 5 more is going to be a negative 8. So those are my two solutions there. This one looks like one I probably want to factor. So I'm going to put an x here and x here. For 40, I can use 8 times 5 is 40, but with an 8 and a 5, I don't see how those are going to go get me to any 6's there. I could use 10 times 4, and if I do 10 minus 4, I can get a 6. Let's try that. Let's do a 10 and a 4, and I want a negative, larger negative value, so I have negative 10 and then a positive 4 to give me 10x, and add 4 more, it gets me negative 6. So what are my x's going to be here? It's the opposite, so I'm going to have a 10 and a negative 4 become my zeros, and my solutions there. Okay, there you go. Okay, looking at the next one, this is one we have to kind of look at the pattern and figure out linear, quadratic, or exponential. So to go from 1 to 3, it is plus 2, but it's also times 3. So I have to decide, am I going to be doing plus 2 or times 3? Well, what happens from here to here? That is a times 3. So we're going to use a times 3 multiplied by 3. That's what's happening between each one. Times 3, times 3, times 3. When the multiplication pattern continues all the way down like that, we consider that to be exponential. Okay, on this one we're going to be adding 3, adding 3, adding 3. So we're just adding 3 each time. So nothing changes, so that's going to be something that is just linear. If all you're doing is adding 3 and the first time you go through it, that's all you got. Here we're going up by 3, and then we're going up by more, and then more. So we're going, in this case, we're adding 3, and then we're adding 9, and then we're adding, it looks like 15, right? So there's not a huge pattern there, but what happens between these ones, here to here and here to here? This is plus 6 and plus 6. And when you get into that second kind of column, if you see your pattern in the second column, that tells you that you're dealing with a quadratic. All right, so that's that one. Let's see anything after that. Nope, that's it. That's it for today. Hope that helps you out, and good luck on your upcoming test. See ya.